Unified Package Building (UPB) is an SAP component designed to unify the different packaging approaches that previously existed across SAP applications. Its main objective is to enable the standardized and optimized construction of packages and pallets within logistics processes. Before the introduction of this functionality, each SAP application used its own packaging engine with different rules and different outcomes. This led to inconsistencies across logistics processes, making a unified packaging strategy necessary. Unified package building does not replace existing packaging engines. Instead, it integrates them under a single logic, allowing the use of packing instructions, package builder, and packaging specifications, depending on the business process. UPB is a reusable component within SAP S/4HANA and can be consumed by multiple logistics applications such as SAP Transportation Management, SAP TM, Extended Warehouse Management, EWM, and Logistics Execution, LO. Its operation is straightforward. It receives products as input, applies packaging rules and constraints, and returns an optimized package hierarchy as output. Given a certain product quantity, UPB determines a packaging hierarchy that minimizes the number of top-level packages. Among the available package building modes are rule-based packaging and detailed mixed package building, where the optimizer determines positions and orientations of the products. UPB also supports advanced features such as separator materials, packaging hierarchy depth, product incompatibilities, orientation profiles, and loading sequences per package. This process considers material master data, the UPB profile, and additional configuration settings. It is important to understand that UPB is responsible only for building the packaging structure. The responsibility for persisting this information lies with the consuming application such as SAP TM, EWM, or LO. The behavior of unified package building is primarily defined through the UPB profile. This is where packaging rules, the packaging engine, and constraints that control how packages are built are configured. In summary, unified package building enables optimized and standardized packaging, aligning logistics planning with real execution and improving end-to-end process efficiency. Let's assume the requirement is to transport 160 units of a finished product, packed inside a single package. We start by reviewing the dimensions of the finished product box, and based on this information, we calculate proportionally the dimensions of the package that will contain these 160 units. A key point in this process for our testing is defining the package as a closed box. This prevents issues during the load planning process related to stacking rules. Now, let's begin by going to transaction MM01 and creating our finished product material based on a copy of an existing one. We assign it a name, Shoe01, indicate that it belongs to mechanical engineering, and set the material type as finished product. We select all views and extend them one by one. We enter the plant and storage location data already known in the system and copy them to the same storage locations. Now we go through each view. We update the description and specify that it is a Nike tennis shoe box. We enter the gross weight. As reviewed earlier, an average shoebox weighs 1.5 kilograms gross, and the net weight is 1 kilogram. We remove the volume, then enter the dimensions first. We complete each view, leaving the remaining fields unchanged, focusing only on dimensions and weight. We save and move to transaction MM02 to edit the material.
It really helps keep this channel growing.
Under additional data, units of measure, we adjust the dimensions. Length 30.5 centimeters, width 20 centimeters, height 12.5 centimeters. We set the unit of measure to centimeters and calculate the volume, which results in 0.008 cubic meters. Next, we define the stacking factor, which determines how many products can be stacked on top of each other. The pallet equivalence is predefined as 150, but in our case, the pallet, represented by the packaging box, will be equivalent to 160 units. We save the changes. Now we return to MM01 to create the packaging material. We copy an existing one, assign a new material number, and set the material type as packaging. We select all views and copy the same plant data. In the sales, general/plant view, we define the packaging as a closed box. We remove the allowed volume, which is only relevant for open packaging. We proceed to MM02 to edit the packaging dimensions. Under additional data, units of measure, we enter length 1.22 meters, width 1 meter, height 1 meter. The calculated volume is 1.22 cubic meters. We set both gross weight and net weight to 2 kilograms, as they are the same in this case. The stacking factor is set to 3, meaning the box can support up to 3 boxes stacked on top of it. We save the data. With this, we have successfully created both the finished product material and the packaging material. The next step will be to create the unified package building profile. Okay, let's create our profile. We go to SPRO, Transportation Management, Planning, Unified Package Building. First, we define an optimizer profile. We take the standard profile and assign it a name. We set the runtime to 2000 milliseconds, the optimized runtime to 50%, and the optimizer focus to 50%. We leave the remaining options as they are. This configuration defines how the optimizer profile behaves when executing the operation. Next, we create a new entry for our unified package building profile and assign it a name. Under logging level, we select all messages so that all messages generated during the process are recorded. In the package building engine, we keep package building as is. Now we move to the basic settings required for this profile. Under Mixed Package Building mode, we select Detailed Mixed Package Building. This enables the lower section, where we can define the sequence in which products are packed. We specify that packaging should be done in layers only. Here, we select the optimizer profile we previously created. Next, we define the generalized unit of measure. Under General Settings, we set the unit of measure to pallets. This is the basic configuration required for our profile. We save the settings. Now we move to SAP Fiori and search for our freight unit building rule. We list the existing rules and edit our test rule to assign the newly created profile. Under Unified Package Building, we select our new profile. We specify that the result should be created as a hierarchy. For the maximum number of packages at freight unit level, we do not set a limit. We save the changes. The next step is the assignment of the package type. Up to this point, we have completed almost all the configuration required for the unified package building process. However, if we were to create a transportation requirement that generates a freight unit, the unified package building process would not be executed yet because we still need to define the building rules. So, let's proceed with that in the application change package type assignment. This can also be done via SAP GUI using the transaction indicated in the comments. In this application, we determine which package type is appropriate for a specific combination of product, business partner, customer, and location, or simply based on the product. Additionally, we can define physical constraints such as maximum height, maximum weight, or stacking restrictions for the product. The package builder uses these values and rules to build and select the appropriate packaging for specific products based on this combination. Now we go to the structure location, business partner, product, and we select our product number. For the purpose of this exercise, we will only maintain the product without any additional combinations. Next, we select the packaging material that we previously created. Here, we have several rules that we can define. We will set the package class to pallets. One example of a rule we can define is the maximum weight, meaning that the package to be built must not exceed, for example, 300 kilograms. However, we could define many other rules at this point. For demonstration purposes, we will keep it simple and save the configuration. Perfect. Now we are ready to execute and test our unified packaging process. Let's validate the configurations we have completed so far. To do this, we navigate through the SAP menu under Logistics, Transportation Management, Administration, Unified Package Building. First, let's check package config consistency under Package Building. We enter our shoe product and, in the category, we keep only material and package type assignment. We execute the check and run the selected validations. At this point, we see an error displayed in red. Let's expand it to understand the issue. The message indicates that the package type assignment does not have a maximum height maintained. Therefore, we need to verify this in the packaging assignment. Indeed, we can confirm that the maximum height has not been maintained. This results in an error. This happens because our packaging material is defined as a closed package, which requires a maximum height to be specified. We maintain the maximum height and execute the check again. First error is now fixed. Now let's check the other one. This might be related to the product volume and data or dimensions data, which are related to it. Let's check it out in material master data. Indeed, I made a mistake in the length entry. It should be 30.5 centimeters. That is why the consistency check raised an error, as the volume calculation did not match. Let's execute the check again. Now everything is shown in green, which is the expected result. This validation step is very useful whenever there are issues during package creation, as it guides us to the exact area where adjustments are required. We can also validate the configuration of the packaging material itself. When we execute the same process for the packaging material, the system only returns material master related information, since package type assignment is not relevant for packaging materials. Next, we navigate to the Unified Package Building Test cockpit. Here, we select our UPB profile. This transaction allows us to simulate the creation of a freight unit with its items and visualize the result before creating an actual transportation document. We enter a quantity of 10 pieces and select the execution mode for package creation. Choose Create Packages. The system creates the package assigned to this product, in this case package 160. In the results list, we can see all length, weight, and restriction calculations used for package selection. Two important fields to validate are whether the product or package is stackable and whether the package is completely full. We now enter a quantity of 160, which we know is the maximum capacity per package. The system again creates a single package. And we can see that the incomplete indicator is no longer displayed, confirming that 160 is the packaging limit. Next, we enter a quantity of 320. Based on our configuration, this should result in 2 packages. The system behaves exactly as expected. If we enter 1600, the system creates 10 packages. This cockpit helps us anticipate how packages will be created and to visualize the resulting packaging hierarchy. Additionally, in the message log, we can review all decisions and calculations performed by the optimization process. If something goes wrong, any errors are clearly displayed here. We can also validate the process using another product. Even when using the same UPB profile, the selected package may differ because the package type assignment is product specific. In this example, the package is not stackable. As discussed during master data configuration, it is critical to correctly maintain the stackability indicator, as this impacts subsequent load planning rules. Another validation option is to provide a freight document number along with the UPB profile. If such a document exists, the system retrieves its items and allows us to validate the execution of the package building process directly. When we execute, the system displays the same results. Any errors would also be visible here. Alright, let's get started with our demonstration. We are going to create a sales order. Let's take a look at this example. Okay, let's select our material. Let's enter 320 units, so the system creates 2 packages for this material. Now we are going to add another material that is assigned to a different packaging type. And for this other one, we'll enter around 30 units. We save. Okay, now let's display our freight unit. Good. Here we can see that we have 4 line items, from which we can infer that 4 packages were created. Let's go into the document details. Let's check the items. So here we can see that the package building was executed correctly. We see 4 packages, and 2 of them belong to different assignments. We can see that the package name is different from the one above, and which product is assigned to each one. We can see one package with 1 unit, one package with 160 units, and another package with 29 units. Now let's remove this material. And we are going to change the quantity so that it creates only 10 packages of this material. Every time we update our sales order, the freight unit building rule will run, so the package building will be regenerated as well. That's exactly what I want to show you here. We update and you can see that the item list is refreshed. All the packages created are the ones we defined, okay? Complying with the rule that each package contains 160 units of shoeboxes. Now let's do another exercise. We are going to change the assignment rule to show how it affects package creation. Let's go to our assignment. Here, for example, we are going to change the maximum weight. Right now, it is 300 kilograms. Let's change it to 100. This will limit the package so that, even if it is not filled with 160 shoeboxes, the weight limit will prevail. So, let's save and go back to our sales order and modify the quantity. and now it creates 3 packages. If we look at the gross weight values, they have changed. Now we see 99.5 kilograms. None of them exceeds 100 kilograms. So you can see that changing the assignment rule directly impacts package creation. Now the quantity is 65, so our packages should not be completely full, but the weight limitation forces the system to create them with that quantity. Now let's make another change. We'll set this back to 300. Let's test again and leave it as it was before. We are back to 2 packages of 160 units each, and we can see that the maximum weight here is 242 kilograms. So the system will always allow this quantity per package, since the gross weight limit in our assignment is 300 kilograms. Okay, another exercise we can do is to copy this rule and assign a different key, for example, a different business partner, another customer. This means that this rule will only apply to that customer, okay? Let's remove the previous one. Now let's create a new sales order for this customer. Or better yet, let's first modify the one we already have to see that the package is no longer being created since the rules no longer match. Okay, let's go to our freight unit. And here we can see that the rule was not applied. Why? Well, because the keys do not match this combination of business partner and product. Now let's create another sales order for customer 02 for the same product. A quantity of 3,200, which should give us 20 packages. Let's display it. All right, it looks like it created our 20 packages. And you can see that the rule did apply to this order. That's because it is only within the scope of this product and this customer. All right, with this we conclude the tutorial.
I hope you found this video helpful. Don't forget to like, share, and subscribe.